Welcome to the Cypress College Math Review on Special Products. In this review, we're going to look at three special products. The first is the product of sum and difference. The second is perfect square trinomials. And the third is the sum and difference of two cubes. First, we'll take a look at multiplying the sum and difference of binomials. And you can see the rule here from your algebra class. When you have a plus b times a minus b, the result is a squared minus b squared. So if we apply that to example 1, we see we're going to get 6x squared, which is the first term squared, that's like the a squared here, minus 5 squared, because that's the second term squared. Now we have to use a rule from our algebra class that when you have a product raised up to a power, like we have here, 6 times x is being raised up to the power of 2, then each factor gets raised to that power. So our result is going to be 36x squared minus 25. In example 2, we're applying the same rule. So here we have the quantity 3x squared minus 7y cubed times the quantity 3x squared plus 7y cubed. And applying the rule, we're going to get quantity 3x squared raised to the second power minus quantity 7y cubed raised to the second power. Now here we're going to be using that same algebra rule where when you have a product raised to a power, each factor gets raised to that power. Then we also have to use a second rule from algebra where when we take a power to a power, then you multiply the exponents. So here we're going to get 3 squared is equal to 9, and then we'll get x squared squared. We have to take 2 times 2, and we get x to the 4th, minus 7 squared is 49, and then y cubed raised to the second power. We multiply 3 times 2 to get y to the 6th. And our solution is 9x to the 4th minus 49y to the 6th. Next, we turn to factoring the difference of two squares, which is really just the reverse of what we did in examples 1 and 2. Let's check out example 3 here, where we have to factor 16y squared minus 9. Now, 16y squared we can think of as the quantity 4y squared, subtracting 9, which is 3 squared. Now, if we use our rule from algebra here, we see we're going to get the quantity 4y plus 3 times 4y minus 3. In example 4, we have to factor 4x to the 6th minus 25y to the 4th. So first we need to write these as the difference of two squares. 4x to the 6th can be replaced with the quantity 2x cubed squared minus 25y to the 4th can be replaced by the quantity 5y squared squared. And now we use the rule and we get 2x cubed plus 5y squared times 2x cubed minus 5y squared. Next, we review the rules for squaring a binomial. And you notice that the only difference between the quantity a plus b squared and the quantity a minus b squared is adding the middle term or subtracting the middle term. So let's look at example 5 and expand quantity 3x minus 2 squared. So applying the rule here, we've got the first term, 3x squared, minus 2 times the first term, 3x, times the second term, 2, then plus the second term squared. Now simplifying, we get 9x squared minus 12x plus 4. In example 6, we're going to expand the quantity 5x cubed plus 7y squared. So applying the rule here, we have the first term, which is 5x cubed squared, plus 2 times the product of the first term times the second term, plus the second term, 7y squared. And simplifying that result, we get 25x to the sixth plus 70 x cubed y plus 49 y squared. In the next two examples, we review factoring perfect square trinomials. Looking at example 7, we have x squared minus 8x plus 16. And this could be rewritten as x squared minus 2 times 4 times x plus 4 squared. And then you can recognize that this looks like a squared minus 2ab plus b squared, and write the factorization as x minus 4 quantity squared. Now, as you get better at this, you will get quicker at being able to go right from the perfect square trinomial immediately to the factoring. In example 8, we're going to see if we can write this perfect square trinomial into the form here, a squared plus 2ab plus b squared. So the first term, easy enough, we write the quantity 2x squared. Now the second term, if we try factoring out a 2, then we would need 2 times, now we've already said our first term is 2x, so that has to be 2x here, and then that means our second term would have to be 5y, so that 2 times 2x times 5y equals 20xy. Then the third term is quantity 5y squared, and then we can see we can write this as quantity 2x plus 5y squared. Next, we're going to review expanding a binomial cubed. In example 9, we have the quantity x minus 4 to the third power. So let's apply the rule here. And we see the first thing we have to do is take the first term to the third power. So in our case, that will be x raised up to the third power. Next, we subtract 3 times the first term squared, so x squared, times the second term, 4. Next, we will add 3 times the first term times the second term squared. Then last, we will subtract the last term to the third power. Now when we simplify, we're going to get x cubed minus 12x squared plus 48x minus 64. In example 10, we'll be expanding the quantity 3x plus 2y to the fifth to the third power. Applying the rule, we see we have to take the first term to the third power, so that's going to be 3x to the third power plus 3 times the first term squared, 3x squared, times the second term, 2y to the fifth. Then we have to add 3 times the first term, 3x, times the second term squared, so that will be quantity 2y to the fifth squared. And then last, we add the second term cubed, so that will be quantity 2y to the fifth cubed. Simplifying this, 3 cubed is 27, so we have 27x cubed. Now in this second term, we have 3 squared, which is 9. Take that times 3, we get 27. Take that times 2, and we get 54. Then we've got x squared y to the fifth plus, in this third term, we have 2 squared is 4, times 3 is 12, times 3 is 36. We have x, and now we have y to the fifth squared, so we know that we have to multiply the exponents and get y to the 10th, plus 2 to the third is 8, and y to the fifth raised up to the third power is y to the 15th. In this last section, we'll review factoring the sum or difference of two cubes. In example 11, we have x to the third minus 125. So the first thing to notice is that we can write this as x to the third minus 5 to the third, because 5 times 5 times 5, which is 5 to the third, is equal to 125. Now that we have it written as the difference of two cubes, we can apply this rule. So then the factorization is going to be quantity x minus 5 times quantity x squared plus x times 5 plus 5 squared. Simplifying this, we get x minus 5 times x squared plus 5x plus 25. And that's our factorization. In example 12, we want to factor 27x cubed plus 64y to the sixth. And the first thing we want to do is get it into the form of a cubed plus b cubed. So the first term can be written as the quantity 3x cubed plus the second term can be written as the quantity 4y squared cubed, because remember, a power to a power you multiply. Now we have it in the form a cubed plus b cubed, and we can apply the rule to get the factorization. So this is going to be quantity 3x plus 4y squared times the quantity of the first term, which is 3x squared, minus the first term times the second term, so we're going to have 3x times 4y squared, and then we have to add to that the last term squared, so we're going to get plus quantity 4y squared squared. Simplifying, we get quantity 3x plus 4y squared times the quantity 9x squared minus 12xy squared plus 16y to the fourth. And that's our factorization. For some extra practice, you can try these problems on your own and then check with the answers below. Good luck with your multiplying and factoring of special products.